Okay, those of you that are still quizzing, wrap it up as quickly as you can. We're going to go ahead and get started. These are homework problems, and it's just a matter of you practicing typing equations in on your calculator. I do want to remind you, and you know this, when you hit, I'm looking at a problem like number 21. As soon as you hit the ON button, what automatically pops up? A parenthesis, right? And that's good. But when you put this in, you're going to need to physically put a second set of parentheses around your denominator. Anytime, not just with logarithms, but this is going to happen with our trig functions in the next chapter. It happens all the time. Anytime you have more than one thing, more than an x, more than a 5, in your denominator, you have to put it in parentheses, okay? No matter what. So make sure that as you're putting these things in, if your denominator has multiple items, make sure that you put it in parentheses, okay? All right, so I'll leave you to do that tonight. You can figure that out. What we need to do now is take a look at a pretty significantly tough problem. So would you look at problem number 30? Do not be frightened of it, but understand this is going to be a little bit out of our comfort zone. Now that I got you all psyched out, do you have any idea how you might start? Multiply by 2. Any idea what we might do next?
Did you make the exponent?
Okay, now remember, these are being added,
Okay.
so there's no operations that we can do. That's kind of like, it's not the same exact thing, but it's kind of like this. If you're being added, there's nothing to do with the exponents. What does this mean, though? It means 1 over. So let's rewrite that as 1 over 2 to the x. Does that make sense to everybody? All right, now do you have an idea what we might do? We have a fraction in our problem now. If we multiply everything by 2 to the x, it would get rid of the fraction, right? So I'm going to multiply everything by 2 to the x. Now, this is 2 to the x times 2 to the x. Would you agree that one way of writing that would be 2 to the x squared?
Yeah.
It's something times itself. Doesn't that mean it's being squared? What's this? 1. Do not multiply these. Remember, we've talked about that. This stays 6 times 2 to the x. Now, I'm going to rearrange things. Basically, just getting my equation set equal to 0. And now here's where I want you to stretch yourself for a second. Maybe you see it already. I have something squared. I'm going to call 2 to the x m. This is m squared. Minus, what's this?
6m.
6m plus 1. Now wait a minute. If you found this equation somewhere, would you be able to solve it?
Mm-hmm.
What would you do with this equation?
Quadratic
The
formula.
quadratic formula? If it factors, you would factor it. You could complete the square on it. Let's use the quadratic formula on this equation right here. So m equals negative b squared minus 4 ac all over 2. Alright, double check that. I just kind of got on a roll. This is a hard problem for sure. I mean, nothing we've done so far has been hard, but there's a lot to do here. We're not anywhere near done. Alright, did I do my arithmetic right?
Yeah.
Everything okay? Alright, I'm going to get a couple decimals for this now. And normally don't like to do that, but I've got a lot ahead of me, so I'm going to go ahead and get a couple decimals for that. So what is that? One answer is 5.828, and the other one is 0.1716. Now, I gotta erase this over here, but did the original problem have m's in it? So those are clearly not the answers to the question, because the question wasn't find m. There wasn't even an m in the problem. What was the question? Find x, right? So what's this m thing I stuck in there? M is 2 to the x. It's the substitution. This was too complicated to me. I wasn't sure what to do with this. So I recognized it was a simple little quadratic equation. It just had a weird variable in it. But now I need to go back and say, okay, 2 to the x equals 5.8284, or 2 to the x equals 0.1716. Do you see what I'm doing? I'm kind of unsubstituting now. I let m be 2 to the x, but now it's time to go back to 2 to the x. How do I solve that? How do I solve an equation that has a variable as the exponent and I can't get a common base? So I'm going to take the logarithm of both sides. And one x value will be the log of 5.8284 divided by the log of 2. So 2.543, did anybody match that? And then the other x value, I'll do exactly the same thing, right? So it'll be the log of 0.1716 divided by the log of 2. I got negative 2.543. Oh, that's interesting. Okay, that was kind of hard. Let's do the one, or one of them that I assigned for homework. So let's take a look at number 29. All right, so let's go through those steps again. I know it's a challenging problem. Here we go. 2 to the x minus 2 to the negative x over 3 equals 4. Here we go. Step 1. See if we can get through it step by step. What do we do first? Multiply by 3. So 2 to the x minus 2 to the negative x equals 12. Everybody good so far? Okay, now I've had to erase it, but do you remember what we did next?
Make it a fraction.
We took care of this guy right here, right? So that became 1 over 2 to the x. Because that's what we do with negative exponents. Okay, do you remember next? Multiplied by 2 to the x. So that gave me 2 to the x times 2 to the x minus 1 equals 12 times 2 to the x. Is that okay with everybody? Multiply this by 2 to the x, this by 2 to the x, this by 2 to the x. Now at this point is when things get a little bit tricky. You have to recognize that you have 2 to the x squared, 2 to the x times 2 to the x, minus 12 times 2 to the x, if I bring this over here, minus 1. Now have I lost anybody? 2 to the x squared minus 12 times 2 to the x minus 1 equals 0. That is a quadratic equation. Something squared minus 12 of those things minus 1. So if we let m be 2 to the x again, what does this equation really say? M squared minus 12m minus 1. Now you don't have to do that substitution. This is a quadratic equation. You can solve it just like it is. It's a little bit wild when that's your variable. So I said, okay, I'm going to pick a new variable. That's too confusing. So I'm going to let this guy right here be m. So I have m squared minus 12 of those m's minus 1. Now, this is solvable, right? This part we can all do. So m equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's 237. Is that okay? And then I might as well go ahead and say 6 plus or minus root 37. Remember, you can't cancel unless you do all 3. Okay, now what? You remember, what do we do now? We've got m figured out, but m is not the answer to the question. So now we're going to go ahead and get decimal values for that because we know what's coming next, right? What's coming next is right here. Going back to the original variable to the x. So 6 plus the square root of 37, 12.0828. And negative So these are M. Your job is to find X. So what do we do now?
The log.
2 to the X has to equal 12.0828, and 2 to the X has to equal negative 0.0828. Okay, let's, wait a minute. Did you maybe feel a little bit funny about raising 2 to a power and getting a negative number? Is that possible? No. So that's extraneous. We're not going to get an answer out of that. Didn't happen last time because why? Last time both of these M values were positive, so we were fine. All right, so I'm going to have one to worry about. What am I going to do? Take the logarithm of both sides, pull the exponent off, and ultimately type into my calculator the log of 12.0828 divided by the log of 2. I got 3.595. What about you?
On the last problem, one of the answers that we got was a negative. So like, you can get a negative for your final answer, but you can't plug in a negative.
X can be negative. Can an exponent be negative?
No.
Can an exponent be negative?
Oh yeah.
Can you have 2 to the negative third?
Yeah.
Yeah. You're solving for an exponent.
Okay.
So the fact that it came out negative does not alarm me at all.
Okay.
Here, I'd be logging both sides. Can I take the log of a negative number? No. Okay? All right, those are tough. You're going to get an opportunity to try a couple tonight. What I'd like for you to do now, we really only have one more thing to do. I'd like you in your packet to find the sheet that's called Supplemental Word Problems. Not the solutions. Remember my kids stapled these packets together backwards. Supplemental Word Problems. It's the very first or last sheet in the packet, depending on which way you are looking at it. Do not, I don't want the solution side, I want just the problem side. In order to do these problems, there are some formulas that you will need. Some of the formulas are going to be given to you. We're going to look at problems that use those tomorrow. Today, we're going to look at the formulas that you have to have memorized, and there are basically just 2 of them, both of which you have seen before. I don't know what letters you used before, but this is your compound interest formula. You have seen it before. Don't act like you haven't. This is the formula that we would use for problem number 1. Because in the problem, it specifically says compounded monthly. This is your compound interest formula, compounded monthly. Okay? What is it?
It's like that piece of card.
You turn in a pen.
Yeah.
For real?
Yeah.
You better not be lying to me. I don't want to see it. All right. Compound interest, compounded monthly. All right, so what goes where? Let's just do this first problem and plug some stuff in. Anybody remember anything? Grace. P is principal, and in a money problem or a banking problem, principal is what? The initial investment, right? How much, when you walk into the bank and you hand them money, that's the principal. So what, oh wait, how much would you initially have to invest? Is that my variable?
Yeah.
So I am looking for P. All right, what else do you think? Dan?
Is n the number of times compounded?
N is the number of times per year we compound. So in our problem, N would be what? It says compounded monthly, so N will be 12. There are 2 N's in the formula. Make sure you put 12 in for both of them. Okay, so what's N? N is the number of times per year that you compound. So since this is monthly, N is 12. Lily?
R stands for the rate.
And R is the interest rate, which goes into the formula as a decimal. So since the interest rate is 3.125, it will go in as 0.03125. Emma, did you have your hand up? Were you going to say something?
It's tea time.
T is time in years. In this formula, it's the number of years. So that's 10, so this is going to be a 10.
P your initial.
P is what I'm starting with, so that's my variable, that's the question.
And then you put equals to 4,329.
A is the amount that I end up with, which as Dan just said is 4321. All right, so here's the deal. Every one of these problems we do, compound interest, going to use that formula. Does everybody understand what all these letters mean? So all we've done is taken the information from the problem and put it into the formula. Now we're going to solve it. Any ideas how we're going to do that? We got to get P by itself. So,
Well, could you solve the parentheses and
yeah,
stuff first?
don't we just need to know what that is? And then we'll take 4321 and divide it by that? Okay, so the first thing I'm going to do is make that a 120. I'm not going to mess around with 12 times 10. And now I'm just going to type in on my calculator 1 plus 0.03125 divided by 12 equals raised to the 120th power equals 4321 divided by second answer equals. And we would need to deposit $3,162.60. Okay, make sure you get that number. So I typed in this parentheses exactly as I wrote it. It equals. Then I raised it to the 120th power. It equals. Then I took 4321 and divided it by that answer. On my old calculator, I have to do second answer. Some of you can just highlight it and it comes down in if you have one of the new calculators. Everybody get that okay? So what is that again? That's how much you would have to invest to end up with this much after 10 years. All right, does someone have a hand up? Oh yeah, Grace, what was your hand up for?
So the 120 doesn't go to the P also?
No. Only up here. All right, we're gonna continue this tomorrow. We're gonna finish up with, we'll do some more word problems tomorrow. Okay. Okay, have a great day, everyone. Nick Belkey, I looked at your quiz, you did a pretty good job.